Hey everybody, we're doing another video yet once again about RotorFlight, and this time we have a couple of very special guests. We're going to be talking about PID tuning. So with me, I have Jiawen Bao. Jiawen is originally from China. He came from Beijing to the United States back in 2015. Super smart dude. He went to Stanford grad school, focusing on automatic control, PID control loops, and so forth. And he's been contributing to RotorFlight since 2023. He's been doing a lot of flight performance updates and testing and development and everything else. How are you doing, Jiawen? How are you?
I'm good. It's nice to be here.
Yeah, thanks for joining us for sure. And then of course I have our usual Mr. Alex Dean, BK Hobbies team pilot and RC helicopter addict,
Yeah, I'm an
flies
addict.
every day. Yeah.
Yeah,
So
yeah.
thank you for joining us, Alex. Appreciate it. Have you flown every day in 2025?
I have every day so far. Yeah, I flew today. It was 27 degrees when I flew the M2 for two flights.
No, I'm sure that Jalen would not be flying in 27 degrees. I won't. No
Oh
way.
no, dude. Jalen's
No.
got that hat with the thing that covers his ears. You can
Jalen
do
lives in
it.
California, man. He doesn't deal with 27 degrees. No
He's in
way.
Northern California, whatever. It's cold there.
It's not that cold. No, not 27.
Not so bad.
Anyway, so we're going to be talking about PID tuning, and obviously we thought about Jalen to join us tonight because he's one of the best people out there that can help with anything and everything that has to do with tuning. And disclaimer, there's too many variables, right, Jalen? Like way too many variables. The
Yeah.
servo you're running, the helicopter you have, if you have any vibrations, how your filters are set. There's a million things that can change the way that your tuning affects your helicopter. This is about teaching you the basics of how to go about tuning your machine for your best flight performance.
Yeah, I
Okay.
think the idea is even if you have a base place to start, like an average, and you want to like tweak that last bit out of it, how do you do that? And some of the parameters are different, maybe because they're named the correct thing, and we're used to them being named something different. But now we know what parameters actually change what, and I think a lot of people don't know what that means. So that's the idea here, right?
Okay, so at this point, we're assuming that you already have RotorFlight up and running. You've gone through everything, your setup, your configuration, receiver, power, motors, servos, everything. It's important to talk very briefly about filters because the gyro section under RotorFlight deals with filter settings. And it's important to talk about this because the fundamentals of what we're going to talk to you, especially what John is going to explain to you, has a lot to do with filters being somewhat reduced. As you can see, my first order here, low pass filter is at 150 hertz instead of, I believe the default is 100,
Yes.
I think. Yeah. And then the initial notch is set at 2 with a 3.0 notch Q and a 60 minimum with a maximum of 240. Obviously, this can change. This is very dependent on the helicopter you're flying. So I have a main rotor minimum filter at RPM of 800 for a helicopter that flies typically at 18 to 1900. So I don't know, one third to a half, Jalen. Is that reasonable? So if you're flying a tiny little helicopter at like 4,000, I don't know what the RPM would be for that, but say it's 4,000, you might want this 800 to be what,
Like
2,000
3,000. Yeah.
or 3,000? Yeah. And then your tail, of course, will be much higher. So you'd be at like 6, 7, 8,000 or something, right? So I don't think this is as critical, is it?
Make sure it's not too low, because it might cause issue doing all the rotation.
Say half of your RPM should be more or
Well,
less.
I would say just like a little bit less than the minimum you're running.
So if your main rotor head speed you're looking at is like say 3,000 because you're flying, I don't know, a 420 or a 500 whatever, 3,000, so you want it at like what, 2,000 maybe? Something like
Yeah,
that?
I mean, if you run, if your lowest bank is like 2,000, maybe around like 1,800.
Okay. Okay, so pretty close. And for the tail, about the same? like a little
Yeah,
bit?
just calculate whatever it is based on the tail ratio.
Okay. And then as you can see on these filter settings, the main rotor notch filter is single and 10. Is that
Hmm.
pretty reasonable, Jalen?
Yes.
And then for the second harmonic is single and 3.5, and for the third harmonic is 5, right? And
Hmm.
then for the tail rotor notch filters, we have single with 5, and for the second harmonic on the tail rotor notch, we have single and 5 as well. And then main rotor notch filters is 5.0. So if you copy these filters right here under gyro settings, then what we're going to talk to you about regarding PID tuning should be pretty accurate, right? And again, this is not going to be the answer for your particular helicopter. This is just giving you a basic guidance on what to do or what to look for. All right,
Exactly.
Jalen, take it away. So we have our PID for roll, pitch, and yaw. So
Hmm.
why are we treating roll differently than pitch, Jalen? Is it because of the momentum and the inertia created by trying to swing the boom around on the helicopter? Is that what it is?
Exactly. The pitch has a much higher moment inertia, so which means basically the heli doesn't want to move as fast as roll. You can see it, especially here on the derivative, the 55 here in the scale of a roll is actually 550. So we're using like more than like 20 times of D gain on pitch than roll, like in reality. So what happened here is, let's talk about roll first. The P gain on roll, I would say, is ranging from like 35 to maybe like 70. And also D gain, maybe like I tried 0 to like 40. It doesn't make that big of a difference, in my opinion, because roll is kind of like simpler to control, that I assume. On the pitch, however, it's a lot more critical. Uh,
So, okay, let me stop you for a second. So, you can get away with crappy tuning on roll much easier than you can get away with crappy tuning on pitch. Yes?
yes.
Yeah, and it makes
And
sense because, again, you don't have all the mass trying to rotate all at the same time. Is that the
yeah,
main
and
reason?
usually if you just type the number shown on the screen is probably fine.
So, what would you say would be? So, let's talk about what the average values would be when somebody starts flying. If they don't want to go default on RotorFlight, what would be the lowest and the highest P that you would run on roll? Like you said, like 30 to 70, somewhere in there, depending on the helicopter.
Yeah.
So, if they start at 70, okay, what's the worst that can happen if they start really high on the P gain on roll?
Like a few things will happen before, anything catastrophic. One example maybe if you're doing an elevator TikTok and you can see the skid will kind of bounce a little bit at stop. So it was
Okay.
like the roll will shake a little bit. That is like way before you can, took off and the heli will just like wobble nonstop.
So with the roll, you can go as low as 30 and as high as 70 and not have any adverse effects. Like you're not going to blow your helicopter up with those numbers. Those are very safe numbers, right?
Not very likely.
And with the pitch, you can go what? As low as what? Maybe
I would say I usually run around 100 to like 140.
okay.
A lot of people run the same P game for pitch and roll, and I don't like how that feels. Because the dynamic of the two axes are fundamentally different. Like
Correct.
I don't see why you should run the same numbers there.
I could see that. And the yaw, obviously that's a different topic. We're going to talk about yaw in a minute. But so the proportional gain, it's sort of the instant response of the control loop, right? In other words, if this is too high, it'll be a shake, but that shake will go away very quickly. Am I right or wrong?
Until you go too high.
Too high, correct.
Yeah.
Now let's talk about D before we get into I, because I is a different animal. So let's talk about D. So D and P and D are somewhat similar, right?
D is even more instant than P.
Okay,
Because
okay. So
D is kind of like look at your current rate of difference and they say, hey, I'm trying to predict what you're going next.
okay,
Another analogy for P and D is actually a spring damper, like your car suspension system. The P is kind of how hard your spring is, and the D is kind of how hard your damper is.
okay, okay. That makes
So
sense.
let's say if you have no damper, you have a really strong spring, it will like just like go back and forth, it will go unstable. But if you have just enough damper, it will be like pretty ideal. Like you don't have a lot of bouncing.
Okay, that makes sense. So going back to this, you can do anything from as little as 30 on the P gain for roll and as high as 70 and as little as maybe, I don't know, 50 to 60 and as high as 150 on the pitch,
Oh,
right?
I would say recommend like minimum 90 to about 150
Okay, 90
for
to
pitch.
150. Okay. And then for the D, on the roll, what would your numbers be?
Like
Um,
0 to 50 is probably fine.
okay. And for the
Uh,
pitch?
yeah, like the D on roll is not very critical in my opinion, but on pitch is very, very critical. It's usually around 45 to like 60.
Okay, okay. So
It's,
how can you tell if your P is high or your D is high?
it's actually very similar. So just go back to the TikTok example where like if your disk is like shaking very fast, maybe both of them are high, or maybe one of them are high. But it's very unlikely that with like default like this, you're gonna go very high.
I like what you said about the skids. A lot of times you can't see it on the disc if it's happening very fast, but you can see the skids shaking if you're doing
Hmm.
TikToks in front of you or something. It's more obvious.
Yeah.
You know what your settings are, Alex? Because I know Jowin helped you set up your stuff, but are you similar to what I have?
Very similar. Yeah.
Yeah.
I mean, Jowin talked before about how he likes to start there and then do just micro adjustments. I mean, I would say micro adjustments, Jowin. That's true for most 700s, right? But when you get into smaller helicopters, I'm sure it's
I would
different.
say it's true from like 380 to 700.
Oh, wow. Okay. I haven't really set up another small thing.
If you're flying your helicopter with these settings right here, okay,
Hmm.
and you're not happy for whatever reason, what would make you, for example, increase the P or the D? Or
The
decrease it, or decrease it.
Yeah, so decrease is relatively easy if your heli is shaking very fast on the disk. It might mean that your P or D are too high.
So if your head is shaking very fast, which one would you go down on first, P or D?
I would actually try them both.
Okay.
Another way to look at it is D as a damper, which means sometimes when you try to like stop right on the stick, like elevator for example, it might wobble like kind of fast a little bit. That kind of means the PD ratio is not very good. If it wobbles, it means maybe you need more D gain than P gain. But if it's shaking very fast, it's hard to tell which one first. You might just decrease both of them and see when you can get it.
Makes sense. I know these settings are going to get people like very close to where they need to be anyway.
Yeah.
But okay, let's talk about the integral is easier to tune, in my opinion, because there's maneuvers that are specific to testing if your I gain is too high.
Hmm.
Whereas with the P and the D, it's a little bit more guessing game, right? Don't you agree with that?
Yeah.
Yeah. So, what would be a good starting point for roll pitch for the I? Is this reasonable, 90?
Yes.
What's the lowest you would go to if you were starting out? You're a newbie, you're afraid to go too high, but yet you wanted something that felt pretty good to you in the air. What, like 60, 70, something like that on the I?
I, I, I'll,
100?
I'll I'll say go higher.
Oh, really? Okay. You go to what, like 120, 100,
Yeah,
130? Okay.
because I gain is sort of like the heading hold. It kind of maintains the same orientation.
Correct.
So if you go too low, you might need to start do more corrections in maneuvers.
Yeah, that makes
And
sense.
and if you are not pushing very hard, you probably won't trigger the negative effect on higher eigen.
How do you test to see if your eye gain for roll or pitch is too high?
Oh, usually I put them the same. So eigen is kind of also compensating for airspeed. So if you do Piro, you kind of want the same like tilt angle on the swash in the airspeed direction. But so in order to test whether your eigen is too high, you can a simple maneuver would be a Piro pitch pump.
So like a Piro Pogo type of thing, right?
Yes,
So what are
and
you looking for?
what I'm looking for is the body when you're coming from high to low and you're trying to stop at the low point. If your eigen is too high, it's easy to make the entire helicopter bobble. It's kind of a slow bobble, but it's really clear that let's say your tailbone is not flat. It goes up and down a little bit.
Okay, so you can go as high as you want until you start seeing that, right? And then back it down, right?
Yeah, but another thing is like maybe with no wind, your Piro Pogo is fine, but if
Mm,
there's wind, it might change things. So I
okay.
like to run it around like 85 to like 90 because that's like pretty good in all situations and it doesn't have too much adverse effect on the correction.
It's not an exact science. That's the interesting thing about PID control loops. Is there's a lot of trial and error, testing and flying and getting a feel, right? And there's no right or wrong. There's a lot of different variables, servos. I mean, I don't know. You name it. I mean, the wind, the pilot. You know, the perception of the pilot. Some pilots might have that wobble and they might not notice it, right? And
Hmm.
they're like happy with it, and that's good. That's all good. So, what's up with Feedforward? What is that all about, Jalen? Tell us.
So the feedforward is basically if you have no control loop, that is directly reflects from your stick input to the swash. So
Okay.
if you remember the old flybar days, it's basically equivalent of only feedforward, like the PID are zero and only feedforward is in effect.
Okay, so basically the PID control loop is it's basically bypassing that and just feeding an input to the swash blade or to the servos initially, right? But eventually, of course, the control loop catches up and takes over.
So too low feedforward is actually called undershoot.
Yeah,
Because
correct.
your desired location is more than what you're stopping at, so it kind of goes a little bit more after you stop.
Yeah, exactly. So I had to keep racing this. Jowan, I matched the roll to the pitch
Hmm.
because I tested this with an elevator flip, forward and backwards. And when I let go of the stick, it just felt like it just didn't feel like it was stopping crisp.
Hmm.
And when I got to 130, it just felt like it was just stopping right there. Where I stopped the stick, that's where it stopped. And
Hmm.
so what I did is I took the roll and I matched the pitch, right? That's exactly what I did. Probably I could have gotten away with a much lower feet forward on the roll axis on the aileron side than on the elevator or pitch side, but I
Oh,
just
I
matched it.
actually
Yeah,
I recommend matching the two numbers.
matching. Okay, that makes sense. So I did the right thing. All right, cool. This is your helicopter, or one of them, right?
Yes.
So tell us about what you're trying to do here.
So in the first half of the video, the feed forward is too low. So if you look really closely, when I stop on the stick, the helicopter keeps moving forward.
Yeah, I can
It's
see
kind of
it.
hard to see in some of them, but you can see the tail like drifts down a
Yeah,
little bit.
it's actually it's I can see it not on every single stop, but right there, like on that previous stop, it was kind of obvious right there.
Yeah. Yeah, it just drifts a little bit more, a little bit more.
Yeah, correct. And so after that, you raced it.
Yes.
Okay. So then now you have like a higher feet forward.
You can see how much more crisp it is. How many points higher did you go on feed forward than this?
Oh, I went from like 70 to 115.
Okay, so don't be afraid to turn it up 10 points at a time
Yeah.
and test it out.
I don't
This
think you can mess that up even if you go super high, right?
it's also very blade dependent. So if your blades are slower, you want a little bit higher.
Absolutely. So if you have a super fast, unstable blade, you can get away with less. But if you have a more stable blade, you want a higher feet forward gain. That makes perfect sense. Okay, last but not least, what is boost? Tell us, is that the same as the V-bar paddle sim, which is not really a paddle sim?
I believe so.
Okay, that's what I was thinking. So the boost gives you faster response when you move the stick and you jab it, right? Really hard. That's what
Hmm.
it does, right? Okay. So as you can see, mine, I kept going up and up and up on the pitch, and I didn't on the roll because the roll just felt good to me, and I never felt the need to increase it on the roll.
That can be explained by, you have way more inertia to move on the pitch axis. So maybe you do need to give it a little bit more to start it.
We haven't talked about tail. The tail on RotorFlight is probably one of the best tails I've ever felt. I mean, don't you guys agree? It's like insane.
Yeah, it's ridiculous.
And I think these settings 120, 180, 20, the only instance where I noticed that I had to lower this way down to like 90 was on my Tron Advance that's flying at like 2600 RPM, and it's insanely ridiculous, and there's no reason for that. You know, if you have like a really fast wag on your tail, it's either your P or your D. More than likely your P.
Because we are not using very high D on the tail normally. Like in my opinion, if your servos are kind of slow, you might need a little bit more D. But we're mainly looking at the P.
Yeah, and then if your eye is too low, you're gonna get a little bit of a slow wag, right? So
Yeah.
you need to up that. But I think these are really good settings for most helicopters, 120,
Mhm.
180, and 20. And it's a good starting point. So if you have a little bit of a wag, you can lower the P and the D. And if the wag is too slow, then maybe you need to up the I. Although I think an I of 180 is probably really good.
Yeah,
Um,
and I've seen people go like up to like 450 on the iGame.
oh wow, that high,
Yeah.
huh?
Yeah, so you can go really high. The only problem with being low on iGame like 180 is when you go really fast and do pyro, you might have whipping on the tail.
Because
Increasing iGame helps with that.
yeah, that makes sense. And feed forward, I don't know why I went to 8. I don't think it matters for the yaw. I think you can be a 0 and 0, and it's still good enough.
And
I
one of the things I would point out about the eye gain on the yaw is if you have not set your geometry up correctly, where with the tail blades using the angle measurement, and you go to fly, you're going to notice that whipping that Jawin's talking about, and you're going to
And
have to
that
run a
is
super
right
high eye
here
gain.
under mixer, yeah. So make sure that these numbers are where they need to be for your helicopter. So I think that kind of gives you guys an overview of PID, feet forward, and boost. Okay, so as we move forward, let's talk a little bit about these options. We're not going to cover auto leveling because it's not part of today's video. We're not going to cover rescue or governor, but let's talk a little bit about these other options. So PID control, a lot of these options you don't have to mess with, right, Jowin? Don't touch them. Most of them,
Yeah.
don't touch them. If you don't know what you're doing, don't go there. But pure compensation, of course, you have to have turned on.
Mhm.
And ground air decay.
This is just for safety. When it's underground, you don't want to like, when you take off, it just like tilt on one side.
Yeah, correct.
Yeah.
And then the eye term relax. So tell us a little bit about that.
Yeah, so item relax is kind of a way to reduce wobbling when you stop. So usually we use all of them, like RPY means on all three axes. And the default for me is too low. So the low means a stronger relax, which means you are not likely to see a wobble, but then the helicopter feels loose, especially on stops. So you actually want these numbers to be, relatively higher, like 15, 12, 15 here. That's pretty good. Too high it makes the stop really hard to tune. It's kind of like wobbles fast a little bit.
So you can start at default and then perhaps go up to these numbers, right?
Mm-hmm.
And if you notice any adverse effects, then start to go down again. But if
Yeah.
not, leave it like this,
Yes.
right?
Yeah.
Now here you really don't touch any of this other than HSI offset gain for roll and pitch, right?
Yeah. So what we notice is on the default 35, the helicopter will behave a little bit worse in like high speed, like funnels or high speed hurricanes. And change it to 60 really makes them like more predictable.
Yeah, I noticed that if I'm doing just fast forward flight, right to left or left to right, just going straight and level forward flight, if I jab the collective, I notice this tendency of the elevator to kind of do that as I'm feeding collective. And that's happening on hurricanes and funnels, like you said, Jowan. So I noticed that by racing that up to 60, even 70. I think I have it at 70 on my Ill Goblin. I don't feel that strange interaction between collective and pitch. I'd say you're safe going up to 60 right off the bat, and possibly even higher if you want to. What do you have you tried going really high? Do you know what the adverse effect will be if you go super high on this?
So the adverse effect is this thing behave exactly like an eigen at a higher collective.
Okay. Okay, that
So
makes
if you
sense.
go too high, it's the same thing as eigen too high.
Okay.
In fast forward flight, if it's too high, you're going to get kind of a wobbly disc, slow wobble.
No, it just like when you do like pure pogo and it'll
It'll be
shift.
similar for that. Okay.
Yeah.
Okay.
All right, moving on to main rotor settings. So anything you got to change here, Jowan, that you like to change?
There's one thing that's the
The error decay time.
yes, the error decay time.
Yeah.
The default is on 25. I found it a little bit harder to tune in TikTok, like kind of wobbles a little bit.
Yeah.
I usually run like around 15 to 20. Too low makes a hover like drifty. And
Rifty, yes. I did notice that. And I was trying to tweak that a little bit. I wanted to go a little higher because, yes, on my hover, I feel like it's not as locked in as it should be. So I probably should play with that. But like you said, anything between 15 and 25 is probably okay.
yeah, 25 might make it harder to tune on the like TikTok.
Yeah, correct. Okay. And what about this error decay
Uh,
maximum?
I don't really change that.
Okay, leave it alone. Okay, let's talk a little bit about tail rotor settings. So what would you change in here, Jalen, and why? I know you explained to me about the clockwise and counterclockwise stop gains, and they're directly related to your main tail gain, right?
Tell Pegan.
Yeah, correct. Yeah. They're related to this value right here.
So these are just a multiplier for the tail Pegan on the two different directions.
Okay. All right, that makes sense. So where would you start here? What's a good starting point?
You can do 180 or 165. The actual like the number doesn't really matter. What matters is the ratio between the numbers.
Okay. Okay.
So what I usually do is I will crank my P gain on the tail as high as possible,
Right here.
and just look at the stopping behavior because if the ratio is not correct, one side will stop well and the other side might not be.
Okay. So you just you just basically start increasing until you have a crisp stop. And if you're too high, what will happen?
The problem is a counterclockwise stop. So if when you're doing a left rudder and you try to
Left rudder.
stop, it will like wobble a little bit more than the other side. And you just decrease the 65 to like, I've seen like 50 here.
Okay.
So
Okay.
50 to 100 ratio.
Okay. And if it's a soft stop, you just increase it.
Yeah.
Yeah. What about yaw pre-comp cutoff in hertz?
That usually I don't change.
Okay. Leave it alone. And the cyclic feed forward gain?
Yeah, so this is the cyclic pre-comp. So the feed forward on the top is the feed forward from your stick to the swatch plate or to the tail.
Okay.
It's directly from the stick. But here is, so these feed forward are the feed forward from cyclic to the tail, like the cyclic deflection to the tail.
That's how it compensates for the cyclic input
Yeah.
on the tail. Okay. Same with the collective.
Yeah,
right?
this is a collective pre-comp.
Yeah, correct. So when you jab the stick and you're giving it a lot of collective pitch, then you get a slight amount of tail deflection preemptively or proactively to compensate for your collective input, right?
Yeah. Another thing to notice is actually disabled when it's on the ground, so you can't really see it.
What about the impulse feed forward and impulse
Yeah,
decay?
just leave them at 0.
What about that one? Is 0 too?
It doesn't matter because the gain is what controls it.
Oh, I see. Okay.
So if gain is 0 like this, doesn't matter.
Okay, so I had people asking me, what is this? The torque assist.
So this is what happened with a lot of the micro like motor drive tail helicopter, where you will speed up the main blade to assist the torque on the other direction of the tail. So if you use a servo tail, you don't need those.
So that's only like if you're using like a tail with a motor, right?
Yeah.
All right. So that concludes tail rotor setting. All right. Right as we move on to PID Controller Bandwidth. What is bandwidth, Jowan?
They are all filters.
They're filtered. So touch them, leave them alone. What do you do with them? Are
So,
these default settings, or you gave me these? I don't remember.
Yeah, I gave you this. I found the default a little bit too conservative on the.
So the defaults are higher than this?
The default are lower.
Lower numbers. So you actually have less filtering, so the number is higher, right? These are in hertz? Is that what it is?
Yes.
Okay. So obviously the higher the hertz, the cutoff is higher, so you got less filtering going on. That makes sense. So people can basically use these settings they see right here.
Yes.
And it should be pretty good for any size machine.
Maybe not like the M2 size. Like those are like different animals, but I would say from like 380 to like 700, 800, you can get away with those.
But I do have a question for you, Jowan. Is it going to be different on a nitro model or a model that vibrates more than an electric?
That you have to see the black box.
I can tell you that my settings here for my BK Edition Nitro 90 Tron are the same as I have here on my Tron Dynamic. Basically, same machine, electric versus nitro. So my settings are the same. Now, I'm going to tell you, I don't want to detour the conversation, but going into my mixer, my gyro, my filters, my numbers here for the nitro are different, and that's a totally different video. But I think I have my low pass at 120. There's a few differences here, but when it comes to the PID controller bandwidth, it's the same for nitro electric, at least for me, and it works fine. So. All right, so we don't need to talk about auto leveling, or rescue. We can talk about rescue some other time.
Actually, the rescue and RotorFlight's really incredible.
I hear it works amazing. Yeah. Governor, we're not going to talk about that. All right, we're going to talk briefly about rates. So most of us here, including Jowan and Alex and everybody I know, are running actual. You have all these options: beta flight, race flight, KISS, quick rates. They're all, as Jalen says, different algorithms for how the rates are handled. So you can go straight to actual and just use the actual rates. But tell us a little bit about this, Jalen. So, of course, if you match these numbers, okay, so say I have 290 for max rate on roll. So if I go to 290, 290, and I turn this to 0, that means I have a linear input or output, whatever you want to call it, into
Yeah.
my roll or aileron axis, meaning I will be rotating at 290 degrees per second. Well, how does this really work? Because I forgot. Let me revert. I think I was at 250, 290 with 0.2. What would you recommend for somebody that's new to RotorFlight to start with, or and why? And how does this number correlate to this number and this number right here?
So the expo here is actually not what we're used to. Let's set the expo to 0 for now. And let's say a sensor sensitive, like set to 10. So as you can see, the red line in the bottom, like that draws the curve.
Can we get rid of this so it's easier to
Yeah.
visualize?
Yeah.
So everything is like at 0. So we only see one curve right here. So
Yeah.
we're only looking at roll, which is aileron. So we have this at 10, this is 0, and this at 290. Okay.
So when you're changing the center sensitivity, it basically change, how flat the center of your range is. So this is the parameter that is more similar to what we usually call expo. Center sensitivity is actually the slope that, if the center is extend all the way to the edge, it is
Yeah.
aiming at 10 degrees per second.
When I move my roll, if I peg it, yeah, it's pretty quick, right?
Mhm.
But if that's like half stick, and it's super slow.
Yeah.
So yeah, it's super dead. So I never even thought about the fact that you can run this as low as 10.
Mm-hmm.
It's interesting. I think for beginners, I think something like 180 is more than sufficient for a beginner, right? That's from upright to upside down in 1 second. I think that's more than reasonable, in my opinion. So if you were doing 180, what would be a good starting ratio? Say for math, to make the math easier, if you're starting at 200 degrees, what would be a good ratio? Half?
I would say 50.
So 50. Oh wow. Okay. Okay.
Yeah, that
Okay.
creates a really a slow in the center feel.
Yeah. Yeah. What do you run, Jalen?
I run 190 and 300,
190 and 300. Okay.
but that is like basically linear. That's not very different from linear.
Yeah, and if you match them, that's 100%. That's super linear right there. So
Yeah.
it's super touchy as I move the stick. It's very touchy throughout. What is the expo then?
So expo is actually not what we used to. It doesn't change what the center feels. What it does is it kind of change how much the center sensitivity extend.
That's what I noticed. Okay, so if you go super high,
Yeah,
you can
right.
see how that, yeah, that
The
graph is.
center slope stays the same, but it's more linear in the center and then suddenly jump to a very high number.
Yeah, you can see how, like, when I start decreasing this number and I go, say, way down, how that curve is changing, right? So at 0, there's still a curve right here that almost seems like there's already expo built in, right? But as you start increasing this value, you can see how that curve starts to get more pronounced towards center. And obviously, when you go this high to 1.0, then you have almost no stick input response. But then all of a sudden, it just goes. What would you recommend here? Just leave it at 0?
Yes.
Leave it at 0 and then set this, say, 5200, and then take it up from there. So one thing that I did was I started increasing this number, right? And I don't remember where I ended up. I can revert and we can see 290. But it's interesting because this seems to be different on the different helicopters I have, Jalen. If it's going by the true rate in degrees per second, it should be the same standard for all machines. What makes this different from one to the next?
Yeah, it's all in the PID loop design because we don't have a real eigenvalue. So the eigenvalue actually decays sometimes. So that leaves some room for error. Because if there's no decay on the eigenvalue, it should be the same. Like
Okay,
290 is 290 across all the machines, but then the feel won't be as good.
I see what you mean. Okay, that makes sense. Before we wrap this up, we're going to talk about something that very few people know about, I guess, John. I know Alex does. It's not in the configurator. So this is the tricky thing. You have to have the RotorFlight 2 Lua installed on your transmitter to be able to access this. But this is called, what is it called? Response time,
Yes.
right? So let's show you my transmitter, and you'll be able to see what we're talking about here. So as you go into the sys menu and you go to RotorFlight 2, it loads up the RotorFlight Lua, and then you have to go to the rates, right? And you have your rates like you saw on the screen earlier, and then you have your ability here to copy a rate profile to another rate profile. But then if you keep scrolling, you're going to find these options: roll dynamics, pitch dynamics, and yaw dynamics, and then you have response time, max acceleration for each one of them. So tell us about this, Jalen.
So the response time is basically a filter that is filtering your input. So a lot of people, when they use RotorFlight, they found it like too reactive, especially like doing like parallel maneuvers, like parallel flip, parallel loop. You'll find the disk not moving very smoothly. If you look at the disk, it won't be like smooth. It will be like jagged, like a little bit, depending on the location of your finger. So to solve this problem, you can add a little bit of response time. So let's say like 7 millisecond to like 15 millisecond. That kind of smooths everything out. It adds a little bit of delay to your input, but you are the person to judge, which direction you want
So
to go.
this is in milliseconds, huh?
Yes.
If you want to slow it down to make pirouetting maneuvers easier because there's less response, what would you do? Like 10, 8, 9,
Yeah, about
54?
10.
10. Okay. Okay.
I noticed that around 12 it made it feel more smooth like that, but then like you said, Jowen, it's kind of nice the instant response that you get from RotorFlight. So you kind of have to choose, do you want it to respond immediately, or do you want a little bit of delay that smooths out some of your inputs when you're not really perfect exactly where you wanted to put it while you're stirring or something like that.
So where do you fly it at, Jalen? Yours. Your machines.
About 7.
How about you, Alex?
I have mine at 4 right now, but you do have to be like perfect to get a Piro flip to look nice.
0 is default. If you lower this, meaning adding this, increasing this number, okay, to whatever, say 7. Obviously, you guys are doing this for roll and pitch, but you're leaving the yaw on, right?
Yeah.
Yeah,
No
I've been leaving
changes
the
to
yaw and the collective alone too. But if you find that the collective response is too aggressive for you, which I've had some people tell me, you could turn that response time up on collective also.
So you would just change the response time for obviously roll and pitch, maybe collective if you want to. I don't see the reason why you would want to mess with the tail, right? The yaw. The yaw is not
Yeah, I personally want the tail to be responsive when I want it to be.
as responsive as it needs to be. And what is the max acceleration?
Oh, it's not working.
Not working. Okay. Well, that's an easy answer. Okay, so don't mess with the
There's a
max
reason that's not in
acceleration.
the configurator. Okay.
None of these options are in the configurator, which is fine. Now you guys know I did a video where I explained how to download the Lua for RotorFlight 2, so you guys can tune it from there. So there you have it. That's the response time. All right, so thank you everybody for watching. I hope this video was useful. We try to show you the very, very basics of PID tuning like we talked before, right? There's no perfect formula. PID is strictly dependent on a multitude of factors, including your setup, your head speed, your servos, and your perception of how the helicopter should fly. So there's really no right or wrong, but this should get you kind of give you an idea as to what to do. So I want to thank you, Jalen. I want to thank you, Alex. I appreciate you guys joining me, and thank you, Jalen, for explaining all this stuff. It's fascinating. The sky's the limit with this system. It's just yeah, there's could be overwhelming, a lot of stuff to tune, but once you get it to where you want it to be, you're gonna
Really
be very
amazing.
happy. Yeah, for sure. So thank you again, guys. Appreciate you.
You're welcome.